was asked by a student, how do I do this question? This is on page 417, number 3D, and I'm supposed to find the x-intercepts and the y-intercepts. So we'll do the x-intercepts first. So in general, to determine the x-intercepts, we're going to set y to 0. So if we do that, we plug that into the equation. We have 0 is equal to x squared over 2 minus 18. So the first thing we're going to do is we're going to add 18 to both sides in order to solve for x. So we have x squared over 2. And then we're going to multiply both sides by 2. We'll try and get that x squared by itself. So then we're going to have 36 is equal to x squared. And then we want to square root both sides. This is that special case where there are actually two answers, because whether you plug in positive 6 or negative 6 here, it will come up to 36. Negative 6 squared is also 36. So actually, there are two correct answers to this, and you have to get them both in order to get the point. So if they want it as a coordinate, you would say they have an x-intercept at 6, 0, and another one at negative 6, 0. What about the y-intercept? So the y-intercept, we're going to set x equals 0. So we have y is equal to 0 squared over 2 minus 18. So that's just 0 minus 18, which is negative 18. And make sure when you state your coordinates that you did this correctly. The x-coordinate is 0. The y-coordinate is negative 18. So that is your y-intercept. The next question that was asked was this one here, which is number 7 on page 421. Part A says, estimate to the nearest meter the maximum height of the football above the ground. So they have given us the graph here, and here's the maximum point. They're checking to see if you understand that the maximum height needs to be read off this axis. So the maximum height, according to the graph, is about 20 meters high. Estimate how long it takes for the football to reach the ground. So it started here, and then it goes up, and then back down again. So down here, the time it takes for that to happen is about 4 seconds. The next question says, estimate the height to the nearest meter of the football when it is in the air for 3 seconds. So what we have to do is we have to read off 3 seconds. We got to go all the way up on the graph. Notice where that is. Now that is somewhere in between 12 and 16. So this over here is 14. 15 is somewhere in between. I would guesstimate that this is about 15 meters, I think. It is an estimate. So you read off the best you can. It's somewhere between 14 and 15 meters. The more important thing is, can you use the formula to calculate the exact answer? So in this case, they've given us that the time is 3 seconds, and they want us to use the formula, which they've given us here, in order to calculate the true height. So the height is negative 4.93 squared plus 19.4 times 3 plus 0.6. And if you put that in your calculator, you should get 14.7 meters. And that's pretty close to the 15 that we estimated. The last question asks us to calculate the h-intercept and describe what it represents. So the h-intercept, we can see from the graph that the h-intercept is approximately here. It is very close to 0, but according to the picture, it doesn't look like it's exactly 0. So what the last part of the question is asking us to calculate is, what exactly is this value right there at time equals 0? So what we can do then is we can set the time equal to 0, which will allow us to calculate the exact value of the h-intercept. 19.4, 0 plus 0.6. And what happens is these two terms, because they're multiplied by 0, just drop out, and we end up with h is equal to 0.6. So the h-intercept has the coordinates 0, 0.6. And if you think about what this means, this is 0 seconds and this is 0.6 meters. So what this means is that at 0 seconds, the ball was 0.6 meters high. And if you think about what that means in the context of the question, that means that even before it got kicked, it was already 0.6 meters high, and that was the height that it was coming from. The last question that was asked was multiple choice number 8, and it says, in which of the following relations does a graph of that relation have x-intercepts and y-intercepts with equal values? So what they're trying to get us to do here is to actually calculate the x and y-intercepts. So if we look at this equation from A, we can calculate the x-intercepts first, which means that we would set y equals 0. So we can do that 0 is equal to x plus 8. So that means that x is equal to negative 8. If we calculate the y-intercept, we would set x equals 0, and you have y is equal to 0 plus 8, and y is equal to 8. So in this case, the x and y intercepts are not the same. One is negative 8, and one is 8. So I don't think it's A. We can go and try and do the same thing with B. So B says to do the x-intercept, which is set y equals 0. So 2x is equal to 2 times 0, or rather plus 0 is equal to 7. So this term knocks out because it's 0, so 2x is equal to 7. 5 plus 7 by 2, and x is 7 halves. And if you calculate the y-intercept, then we can see that 2 times 0, so 2y is equal to 7, and that knocks out, so 2y is equal to 7, divided by 2, divided by 2, and y is equal to 7 halves. So in this case, actually, the x-intercept is 7 halves, and the y-intercept is 7 halves. So they actually have the same value. So I would say that the answer is B. If this was a test, I would also check version C or option C just to make sure that I didn't make a mistake somewhere, but this is the correct answer. It has to be B.